Okay, Assalamualaikum warahmatullahi wabarakatuh and hello. Okay, welcome. So today we continue with the transformer, which is transformer test. So if you recall before, okay, if you look here, you have R1, R2, R1, R2, X1, X2, RC and RM. So this parameter is theoretical. So it is basically you will not obtain this easily. Okay, you cannot just obtain this from the datasheet, usually not available. So how to determine this? Basically you have to do two tests. Okay, basically from these two tests you can find the parameter, all the parameter. Okay, R1, R2, which is R equivalent, X1, X2, which is X equivalent reactance, equivalent reactance. Okay, and XM. So basically this test will, okay, you have two tests. Okay, it's called open circuit test and short circuit test. Okay, so basically these two can determine what is the parameters. So for this one you have to you can determine RC and XM, and for this one you can determine REQ and XEQ. Okay, so REQ is basically R1 plus alpha squared A squared R2, and for this one is X1 plus A squared X2. So this one is refer to primary. Okay, this one also the same. If you refer to secondary, this one you have to divide. Okay, if you refer to secondary, this one RC divided by A squared and XM divided by A squared. Okay, this one usually don't happen. And if you refer to the secondary for this one, it's become R1 divided by A squared plus R2 and X1 divided by A squared plus X2. So this one refer to secondary. Okay, and this one refer to primary. So we usually refer to primary. So we start with the short circuit test. Okay, this one I already explained to you. Okay, basically you want to know the parameter. Okay, so and the test is no load test or open circuit test and short circuit test. Okay, how to conduct the test? Okay, so this one also I already provide to you. Okay, open no load test, you can determine the RC and XM. In short circuit test, you determine the resistance and R equivalent and X equivalent. Okay, so we start with open circuit test. Okay, so let me check here. Okay, open circuit test. So you can see here when you do open circuit test. Okay, so basically your circuit is, okay, you use the approximate equivalent circuit. Okay, so if you do a open circuit test, okay, you have a RC XM here, RC XM, and then you have R equivalent and something like this. Okay, so this one is REQ, this one is XEQ. Okay, so when you do open circuit test, so this one is basically I1 bar is equals to 0. So V here will be equals to 0. So basically this is just a redundant circuit. So when you do open circuit test, you just basically find out the RC and XM. That's it. When you open circuit it, REQ and XEQ will be redundant. So how to do this? You need to have a ammeter. You put ammeter here. You put a voltage. Okay, voltmeter here. Okay, and then you could put power meter. Watt. Okay, something like this. So basically you just put 3 meter at the input. Okay, at the primary side you can get the current you can get the voltage and get the power. So based on these three value, you can calculate the circuit. Okay, so how to calculate it? Okay, so basically you have a power OC, okay, from the watt meter, voltage OC from the voltmeter, and IOC from the power the ammeter. So how to calculate resistance RC? So RC is just okay RC and XM. So you want to calculate XC and SM. Okay, because this is open circuit test, you have to focus on open circuit voltage. Okay, so VOC. So if you recall the formula, remember P equals to V squared over R. Okay, P equals to V squared divided by Z. Okay, R. Okay, because P and Q is equals to V squared divided by X. Okay, so if you recall this, okay, make sure you know why. Okay? Because resistance only absorb the real power, actual power, and reactance only absorb the Q power. That's why you only use this formula. So if you rearrange this, you get, okay, this one is POC, this one is QOC. That is how you obtain the parameter. So this one you already measure, but Q you not measure. So how you to obtain this? First you have to find the theta. So theta is basically cos inverse, okay, P divided by VOC, OC, and IOC. So basically this is come from, okay, this one come from P equals to VI cos theta, and theta is equals to P divided by, okay, P divided by VI cos inverse VI. Okay, so this is how you obtain the theta, and after you get the theta, you can calculate the Q. Okay, so this is Q. So Q is VOC IOC sine theta, and then you put here inside here. So basically you already obtain RC and XM. Okay, so the step is this one. So you have to memorize it. Okay, you have to find RC first using V squared divided by P, and then you have to find the theta open circuit. Okay, and then you find the Q, and you have to use the XM is equals to VOC squared divided by Q. Okay, make sure you use the Q. Okay, because this is open circuit, so the voltage is the constant one. Okay, that's why you have to use the VOC. Okay, so this is open circuit test. Okay, now we move on to the short circuit test. Okay, so short circuit test is usually done at the secondary side. Okay, the open circuit test, okay, for open circuit test you done at the primary side. Okay, you test at the primary side, but the short circuit test usually done at the secondary side for low voltage winding. Okay, usually we done at the low voltage winding. So if you draw this, it's something like this. Okay, this one RC XM. Okay, you have R, you have inductor, and then you short circuit it. This one is R equivalent E, X equivalent. Okay, so you short circuit this. So basically when you short circuit this, okay, a lot of current flowing to here, I1 bar. Okay, this is I1 and this is I0. So basically I1 bar is larger, significantly larger than I0. So only around 5% will go here. 5% of I1, okay, will go here. So basically you just can ignore this. So if you simplify this, you ignore that, okay, you basically come out with something like this. Okay, okay, and resistor, inductor, and then short circuit. Req x eq. So because you want to measure the, okay, so basically you can determine this by putting the voltage ammeter, voltmeter, and wattmeter. Okay, and of course, another important thing, because this is short circuit test, okay, you cannot just use the full voltage, okay, V rated. Okay, you cannot do this. If you do this, the transformer will damage, because this is short circuit. Okay, this is short circuit, you cannot use full voltage. So to avoid damaging the transformer, when you do the short circuit test, you have to make sure the voltage, okay, is only 5% of the rated voltage. Means that if you should connect this to a 1000 volt, okay, if you should connect it to 1000 volt, you have to reduce, okay, only to 50 volt. Okay, so this is the short circuit test. You have to reduce the input voltage. Okay, so usually it is with the full current rated. Okay, usually we want to make sure that the current here is full using rated. Okay, for example, is this transformer should output the I rated equals to 5 ampere. Usually we targeted the output of this transformer is 5 ampere also. Okay, so of course the same thing happen. You have to measure this. Okay, you have to place a wattmeter, ammeter, voltmeter, and wattmeter. Okay, automatically you can determine the parameter. So how to do this? So basically, okay, this is the, okay, you can see here, this is referred to primary. Okay, primary, secondary side is moved to the primary side. Okay, how to calculate it is basically something like this. Okay, because this is short circuit, you have to focus on the current. Okay, short circuit test, you have to focus on the current. So Req is equals to P divided by I SC squared. Okay, squared SC. Okay, okay. If you don't know where this come from, so this is basically from P is equals to I squared R. Okay, if you recall chapter 1, okay, this is from this. Okay, so make sure don't forget the square, and then you have to find the Z equivalent, ZEQ. Okay, of course this one is just VSC divided by ISC. You get Z equivalent, and then you have to use a Pythagoras. Okay, XEQ is basically just ZEQ minus REQ. Okay, so this one come from, if you recall, this is REQ. Okay, this is R, this is X, so this is X, so this is Z. Okay, so this one you obtain from this. So you have to make sure you know this formula. Okay, you have to memorize it. Okay, okay, this one is, okay, short circuit test. Okay, this one already equivalent circuit. Okay, this one just ignore. Okay, this is an example on the question how to do the short circuit test and open circuit test. So basically, question about the transformer test is something like this. So you can see here example 4, obtain the equivalent circuit of 200 400. So this one is step up, and okay, alpha is equals to, sorry, not alpha, A is equals to 200 divided by 400 equals to 0.5. Okay, and one phase transformer from the data. Okay, so open circuit test, OC. So from this, basically POC equals to 70 watt, ISC equals to 0.7, VOC is equals to 200 volt. Okay, so basically from this you use the formula. Remember the open circuit test. So RC is equals to V squared divided by P OC. Okay, so V squared is 200 squared divided by P is 70 equals to so RC is 741.43 ohm. Okay, so you have to find the theta. Theta OC is basically cos inverse POC divided by VOC IOC. So you have to memorize the formula. Make sure you memorize it. Okay, so cos inverse 70 200 0.7. Okay, theta OC is equals to theta OC is equals to 87.99 okay degree. Okay, let me check first. Okay, so this is wrong, so 60 degree. Okay, so make sure you check your answer. Okay, and lastly you have to calculate Q first. QOC is equals to VOC IOC sine 60 degree, sine theta OC. Okay, so use your calculator. 200 0.7 sine 60. Okay, so let me use the calculator. So 121.24 degree. VAR. Okay, and lastly XM is equals to VOC squared divided by QOC. So equals to 200 squared divided by 1 to 1.24 equals to 3 to 9.91 ohm. Okay, so this is XM. So basically from the open circuit test you can determine the resistance. So you can see here 571.4 and 330. Okay, that is for open circuit test. Now we continue with short circuit test. Okay, let me adjust this first. Okay, now we move on to the short circuit test. This one can be a little bit confusing. Okay, because it wants to find the high voltage data. Okay, so how to calculate this? Okay, so basically short circuit test is POC is equals to 85 watt 85 watt, VOC is equals to 15 volt, and ISC is equals to 10 ampere. So short circuit test, you can see here current is very high, so you have to be careful. Okay, so that's why the voltage is only 15 volt. Okay, so use the formula. Req is equals to PSC divided by ISC squared. So PSC is 85. Okay, this one is short circuit. Okay, 85 divided by I is 10 squared. Okay, short circuit current is 85. Okay, so Req is equals to 85 divided by 10 squared. So you get 0.85. So you can see here Req is much more larger than RSC. Okay, that is normal. Okay, because this one wants you to look at the high voltage side. Okay, for this case you have to convert the R equivalent to the other side. So Req bar is equals to Req divided by A squared. Okay, because this is referred to secondary, so it is divide. If you refer to primary, you have to multiply. So recall back the formula. So you can see here Req is equal to 0.85 divided by 0.5, I think. Is it correct? Square or multiply. Okay, so you have to be careful with this. Okay, maybe I use R1. Oh, this data is from the secondary side. So when you want to bring this, okay, so Req is equals to, so basically this is number 2. Okay, you want to bring to primary. Okay, primary. So this one alpha squared, sorry, A squared Req, because this is a high voltage side. Okay, means that this data is from the secondary side. So when you from the secondary side you want to bring it to the primary side, you have to multiply by A squared. So A is 0.5 squared multiplied by 0.85, so equals to 0.5 squared. 85 is 0.2125 ohm, okay, or 0.25, okay, 0.21 ohm. Okay, no need to bring too much decimal point. Okay, that is how you obtain the R equivalent. So next you have to find the Z equivalent. Of course, VOC divided by I AC. SC, okay, VSC divided by ISC. Okay, so 15 volt divided by 10 is equals to let me use 1.5, okay, 1.5 ohm. And lastly, you determine the X EQ. Okay, X equivalent is equals to, okay, X equivalent is equal to square root of ZEQ minus REQ. Don't forget the square, Pythagoras theorem. So square root of 1.5 squared minus the original, not the converted to the primary one. Okay, so 0.85, okay, squared. So you have to use the original parameter. So 1.5 squared minus 0.85, don't forget the square. So you get 1.23 or 24 ohm. Okay, so of course if you want to bring to the primary side, okay, so depend on the question. If the question asks you to bring to the primary side, you bring to primary side. If not, just leave it there. Okay, but for this case it want you to bring to the primary side. So X A squared multiplied by X EQ. So you bring to the primary side is 0.5 squared multiplied by 1.24. Okay, so multiply by 0.5 squared. So you get 0.31 ohm. Okay, that is how you do a transformer test. Okay, so that's it for transformer test. We will continue with the voltage regulation.